Welcome to a lesson on the sum and difference identities for tangent. And the goal of the video is to use the sum and difference identities to determine function values. So to find the tangent of a sum or difference, we will need to use one of these identities. If we have the tangent of the sum of two angles, it's equal to tangent A plus tangent B divided by 1 minus tangent A times tangent B. And if we have the difference of angle A and angle B, notice they look very similar, but the numerator is a difference and the denominator is a sum. And we can combine these two identities into one by using a plus or minus sign for the two angles, a plus or minus sign for the sum in the numerator, and a minus plus sign for the sum in the denominator. So if we use a plus sign here, we use a plus sign in the numerator and a minus sign in the denominator. And if we use a minus sign here or a difference, we'll have a difference in the numerator and a sum in the denominator. I did include the proof of the tangent sum identity. We don't have a lot of time to go over it now, but just remember the first step is remembering that tangent theta is equal to sine theta divided by cosine theta, except now we're going to use the sum identities for sine and cosine. So you may want to pause the video and look over this, but it is pretty straightforward. Let's go and take a look at some problems. If we want to determine the exact value of tangent negative 105 degrees, using reference angles we have to figure out how we can add or subtract them to obtain negative 105 degrees. And negative 105 degrees is equal to negative 60 degrees minus 45 degrees. So what that tells us is that we will use negative 60 for angle A and 45 for angle B, and we'll use the difference identity. So let's go ahead and set this up. So the tangent of negative 60 minus 45 degrees is equal to tangent A, or tangent negative 60 degrees. If we're using a subtraction sign, we'll use a subtraction sign here as well. Tangent B, or tangent 45 degrees. Now notice since we're using the difference, angle B is positive 45 degrees. And we'll divide this by 1 plus tangent A, or negative 60 degrees, times tangent B, is 45 degrees. So now we'll go ahead and find these tangent values and then try to simplify this fraction. Tangent negative 60 degrees would be here. Remember, tangent theta is equal to y over x on the unit circle. Negative square root 3 over 2 divided by 1/2 would be the same as negative square root 3 minus tangent of 45 degrees. Here's 45 degrees, y over x, that would equal 1. Divided by 1 plus the product of tangent negative 60 degrees again, which we already found as negative square root 3, and the tangent of 45 degrees we already found as equal to 1. So this simplifies to negative square root 3 minus 1 over 1 minus square root 3. This is the tangent of negative 105 degrees. However, we're often asked to rationalize this. So let's go ahead and multiply the top and the bottom by the conjugate of the denominator, which would be 1 plus square root 3. Let's take this down here. Again, the tangent of negative 105 degrees is equal to this product. Let's start by multiplying the denominator together. These are conjugates, so we'll have 1, and then we'll have plus square root 3 minus square root 3, that's 0, and then negative square root 3 times positive square root 3 would be minus 3. In the numerator, we're going to have a negative square root 3 minus 3 minus 1, and then minus square root 3. Here we have negative 2 square root 3 minus 4 all over negative 2, and this simplifies. We have a common factor here of negative 2. This will simplify to positive square root 3, and negative 4 divided by negative 2 would be plus 2. And this is the value that we were looking for, the tangent of negative 105 degrees. So there's quite a bit of algebra once we find our function values here. So you gotta be very careful and watch your signs and your products. Let's go ahead and try another. It's the same type of question, but now we have our angle in radians. So again, we'll convert this to degrees first. This comes out to 75 degrees. So we're going to use reference angles of 45 degrees and 30 degrees to obtain 75 degrees. But let's go ahead and use radians. So this would be pi over 4, and this would be pi over 6. Now we'll use a sum. So we'll have the tangent of A, or tangent pi over 4, plus tangent B, it's pi over 6, all over 1 minus tangent A, tangent B. Let's start evaluating this. Tangent of pi over 4 is equal to 1. Tangent of pi over 6, 1/2 divided by square root 3 over 2 will equal 1 over square root 3. Next, in the denominator we have 1 minus tangent of pi over 4, which is equal to 1. Tangent of pi over 6 was 1 over square root 3. The next thing we might want to do is clear these fractions. So let's multiply the top and the bottom by square root 3. So we'd have square root 3 plus 1 over square root 3 minus 1. Now again, this is the correct value, but we do need to rationalize our denominator. So let's go ahead and multiply the top and the bottom by the conjugate of the denominator again. So we'd have square root 3 plus 1. So again, what we have is the tangent of this sum, which originally was 5 pi over 12, is equal to, let's start with the denominator. Multiplying this out, we'll have 3 plus square root 3 minus square root 3, and then minus 1. In the numerator, we're going to have 3 plus square root 3 plus square root 3. That's 2 square root 3. And then 1 times 1 plus 1. So continuing to simplify, we have 2 in the denominator. We have 4 plus 2 square root 3. And again, this simplifies nicely. 4 divided by 2 is 2. 2 square root 3 divided by 2 is square root 3. So again, a lot of work algebraically, but we have found the exact value of tangent 5 pi divided by 12. And I think there's one more question. Use an identity to write tangent pi minus theta as a single function of theta. So let's see what happens when we apply this identity for tangent pi minus theta. Our numerator would be tangent pi minus tangent theta, and our denominator would be 1 plus tangent pi times tangent theta. Well, tangent pi on the unit circle would be here. Y over x would be 0 over negative 1, so that would be 0 minus tangent theta over 1 plus, again, tangent pi is 0, so 0 times tangent theta would still be 0. And it looks like it's going to equal negative tangent theta. Okay, that's all I have for this video. Thank you for watching and have a nice day.